The diagram shows part of the graph of y equals e to the sine x. Find the coordinates of the points A and B, and we can see that A is the first turning point for positive values of x, and B is the second turning point, A being a max and B being a min. So y is equal to e to the sine x. Turning points we want to differentiate. So dy dx is going to be, well, we know the exponential function differentiates to itself, but using the chain rule, we then have to multiply by the differential of the inside function. The inside function is sine x, so we're multiplying by cos x. So this is going to be cos x e to the sine x. Dy dx is equal to 0 means that cos x e to the sine x must be equal to 0. But e to the sine x cannot be 0. We know that exponential functions can't be 0. So it must mean that cos x is equal to 0. So where is cos x 0? Well, think about the graph of cos x. So cos x goes like this, and you really should know, although you can find on your calculator, especially if you've got the class pad available, what values are the first two values where the cosine is 0. It's 0 at pi by 2, and it's 0 at 3 pi by 2. Okay, so that means that x is equal to pi by 2, or 3 pi by 2, and this one would correspond to A, and this one would correspond to B. So if we look at A, we would have y being equal to e to the sine of pi by 2. Sine of pi by 2 is 1, so that's just e. If we look at b, y would be equal to e to the sine 3 pi by 2, and sine of 3 pi by 2 is negative 1, so that would be e to the negative 1. So we can now state that A is the point, pi by 2, e, and that B is the point, 3 pi by 2, e to the negative 1.